Hi, my name is Hayden.
Hi, my name is Eric Garoza.
This is our sliding filament theory model, moved to the controlling of this straw. The sliding filament theory models how thin filaments, the actin, and thick filaments, the myosin, slide together in order for muscles to contract. This model only shows one myosin, an actin filament. This process starts when the brain releases a nerve impulse that goes to the axon terminal. When the axon terminal gets the impulse, it releases acetylcholine, which connects to the acetylcholine receptors at the neuromuscular junction, shown through the clear lid acting as a neuromuscular junction. The purple micropipette holder acting as the acetylcholine receptors. The cotton balls acting as the acetylcholine, and the box represents the sarcoplasmic reticulum.
From here, the acetylcholine receptors triggers action potential because of the positively charged muscle fibers. As the action potential travels through the T-tubule, it releases the calcium ions from the sarcoplasmic reticulum, which connect to the troponin. Once the myosin head has an attached ADP molecule and phosphate group, they connect to the open myosin binding sites on the actin, forming a cross bridge. The actin rotates towards the center, contracting the muscle. This cross bridge remains intact until an ATP molecule attaches to the myosin, and the myosin detaches from the actin.
And with that being said, every model has its limitations that lead it away from being a perfect representation. And our model was no different, primarily because we were only allowed to use one movement to show the entire model. The first limitation to it was not being able to show the brain releasing the nerve impulse, moving all the way to the axon terminal. From here, we also were not able to show the nerve impulse releasing acetylcholine, although we were still able to represent it attaching to the acetylcholine receptors. After this step, we were not able to show the action potential traveling through the T-tubule because the sarcoplasmic reticulum was represented by the box itself. Next, we used the same cotton ball that we used to represent ADP and phosphate to represent the ATP because it was the only way to make everything work with one pole. Lastly, one other limitation of our model is that it only shows the muscle contraction in one direction, and it does not show the muscle relaxing all the way after. Thank you for watching our sliding filament theory model.